So now we get to seasonal indices. Now, seasonal data. If you remember what seasonal data is, this is data over time that is heavily influenced by the season. Now remember, season might be summer, winter, spring, but we can also be thinking about months, weeks, or days of the week. So a lot of time we might get this in terms of months. So if you think about a shop like Maya, November, December might be very busy months. They might get very high sales during those months because it's the lead up to Christmas. But so if you're looking at their sales data over many years, you'll see that there's got those peaks in November, December. But that's not usual. So we can't really keep saying, well, those peaks of November, December are going to continue on. And they are so unusual that really we've got to take that seasonality out of it. Another example might be a ski shop. During the summer months, you're not expecting a lot of skiing clothes to be sold, whereas during winter months, you'll be selling far more jackets and things. So that seasonal variation, we want to take out of our plot so that we can better see what the actual underlying trend is. Are the sales of that shop going up? Are they going down, or are they staying the same? We want to see what is happening without that seasonality. And that process is called either seasonal adjusting or deseasonalising. This is what will modify that time series, so remove that seasonal variation. So to deseasonalise, we do something called, we calculate our seasonal indices. All right, so a seasonal indices or seasonal index compares a particular season to the average season. So we think about what is happening that season we're looking at, and compare it to what happens on average. Does it perform more? Is it higher than an average season, or is it less than an average season? Well, it's that comparison that gives us our seasonal index. So a seasonal index of 1.3 means the season is 1.3 times the average season. So it's 30% above that seasonal average, or 130% of that average. So anything above 1 means that season is above the average season. So that sales, or whatever we're talking about, we get more sales that season than what we do an average season. So in terms of language, you might say it's a peak season or a high season. So a seasonal index of 0.7 means that is 0.7 times the average season. So it's 30% below the seasonal average, or 70% of the average season. So you might think that this is when our sales are very much less than what we're getting in an average season. So language-wise, we can refer to this as a trough or a low season. So if we've got a seasonal index of 1.0, so that's the same as an average season. Okay, so that's just saying that it's an average season. So we don't think of it as a peak or a trough. So there's a bit of calculation going on here. Once we deseasonalize it, we can then use that to come up with predictions, and then we've got to re-seasonalize it to get our actual data, which we'll get to later. So that process is called reseasonalising. So the important calculation here is seasonal index. So that's our seasonal index, is the value of the season divided by our season average. So our season is a month, a quarter, or whatever it decides to be. This is a handy little tip though. The sum of the seasonal indices equals the number of seasons. So if we've decided that our season are months, all the seasonal indices, all 12 of them, will add up to 12. So it's a nice little thing to figure out whether you've done your calculations right. So there are a few calculations here that you're going to have to do. To deseasonalise, to take that seasonality out of our figures, we get the actual figure and we divide it by our seasonal index. So we've gotten our seasonal index from our value of the season divided by the average of all the seasons. That gives us our index, seasonal index. And then to get our deseasonalised figure for that season, we get our actual figure and divide it by that seasonal index. And that gives us our deseasonalised figure. Now we'll do some examples of this, so I hope you can then keep up. Now, when we use our deseasonalised figures to plot a line, and what do we do when we plot lines? We tend to make our regression lines. We'll come to that in a bit later, but this is what we do. Once we make our predictions, that's with deseasonalised data. We've got to put the seasonality back into it. And so we get our deseasonalised figure and times it by our seasonal index to get our actual figure. Now I'll do a few examples from this and hopefully it'll make sense to you. Please watch the Ed Rollo videos as well and do the exercises from the book. Okay, this can be a hard one. Also, please ask me questions.